Let's talk about the inner solar system. The rocky planets of the inner solar system are not all the same. The Earth we think is special because it harbors biology. The low-mass planets in the inner solar system and the small moons are unlikely to ever host life. They have bare surfaces exposed to deep space. When a planet or a moon is low mass, it can't hold an atmosphere. The atmosphere operates to protect the surface not just from cosmic rays, but from extreme ultraviolet radiation and from impacts from space. So we see pitted by craters the surface of Moon and Mercury that is quite different from the surfaces of Venus, Mars, and even the Earth. Comparing planets in the inner solar system, we see that by far the closest twin to the Earth is Venus, almost identical in mass, size, and interior structure. By comparison, Mars is quite small, much lower mass. To geologists, Mars is expected to be on the edge of geological activity, with barely enough mass to drive volcanism, whereas Venus and the Earth are heavily volcanic worlds, with magma flows and situations where large parts of the surface have been coated by lava in time. Mercury and the Moon are dead geological worlds, too small to have tectonic activity and too small to have much interior heating, and also no atmosphere. The general principle that's interesting for small rocky planets is the idea of size and how it relates to the dynamism of a planet. The smaller planets and moons are geologically dead. When a planet is large enough, it can have tectonic activity. Biologists have speculated that magma flow, tectonic activity, and energy exchange caused by this are dominant issues in geochemical cycles and in fact facilitate the development of biochemistry. That's speculation. As long as we only know of one world with life on it, we may never be able to test that idea. The second issue is distance from the star. Considering two planets of equal size, the temperature will depend with the inverse square of the distance from the star, which dictates the energy arriving at the surface of that planet. A planet close to its star will not only be heated more by the star, but it may be unable to hold an atmosphere because the equilibrium temperature implies a velocity for the molecules above the escape velocity from that planet. The first gases to escape in this situation are the light gases, because for a given temperature they have the largest velocities. So, on the Earth, we anticipate that any hydrogen or helium that may have remained after the Earth formed quickly escaped into space, leaving the Earth to retain the heavier gases of nitrogen and oxygen. The oxygen, a substantial component of the Earth's atmosphere amounting to 18%, was not originally present. It was produced by biology on the early Earth, involving microbe metabolisms. Far from a star, the same-sized planet will be cold. Its gases will be retained, but some of them may actually be in liquid or frozen form. Another feature of small rocky objects that's obvious when we look at images is their heavy cratering. With no atmosphere and no erosion, when we look at the surface of the Moon or Mercury, we're looking at a map of the history of cratering over 4.5 billion years in the solar system. Most of the craters were put there in the first 100 million years or so, when there's a lot of stuff left over from the formation of the planets. The impact rate of large stuff, particularly, declined exponentially and is now at a very low level. But these pristine surfaces preserve the entire history of the planet in space. The Moon would have seemed to be one of these boring worlds, not geologically active, no atmosphere, the surface littered by craters, but it's turned out to be a little more interesting than that. In the last 5 or 6 years, a series of missions have demonstrated that there's a significant amount of water in frozen form built into the surface, the top layers. This was a surprise when it was discovered. There may even be more of this ice in the permanently shadowed regions near the pole of the Moon and in heavily shadowed regions at the edge of craters. With the cold temperature of the Moon's surface and the lack of an atmosphere, water cannot exist as a liquid. It's surprising that we know there is now water on the Moon in frozen form. Couldn't we have learned this from the Moon rocks brought back by the Apollo astronauts? Turns out there were clues that there was water in frozen form on the Moon in terms of hydrated minerals in the Apollo rocks, but the clues were subtle. These recent space missions with very excellent instrumentation for looking for water have confirmed the amount of water. The amount is not trivial. If you took a ton of lunar regolith, regolith is a technical term for the pulverized soil at the top inch or so of the Moon's surface, a ton of this would yield a liter of water. A ton is about the amount of regolith that would fit in a 1 meter cube. That's an interesting amount for space scientists and people who imagine colonizing the moon, because machines exist and have been prototyped by NASA for extracting that 1 liter from a ton of moon rock. So we could go to the moon and from the rock not only extract water, but also the oxygen required to set up a settlement. In other words, all the technologies exist and have been proven to provide the key ingredients to set up a lunar colony. The evidence for water frozen into the moon's surface is subtle, but it's convincing. It's been detected by 4 different missions over the last decade. It's been detected by all these missions in the top few millimeters of the moon's surface. LCROSS also did the clever trick of launching a part of the spacecraft into the moon's surface and then spectroscopically examining the plume of debris that came off after the impact, showing that that debris contained frozen water. The kind of data that's used to determine whether or not water exists is infrared spectroscopy. Water vapor in the Earth's atmosphere, or water ice, has strong molecular absorption in the near infrared. The instruments aboard these spacecraft did infrared spectroscopy by reflection of the surface and showed the characteristic signature of water. It's not able to mistake it for anything else. There's no question that water exists. However, it is a puzzle what the origin of this water is, since the moon was presumed to have been baked dry and blasted dry by all the radiation from space. One idea for where the water in the moon's soil comes from is from a reaction that happens at the lunar surface when the solar wind hits the moon. The solar wind is composed of high-energy particles and extreme ultraviolet radiation from the sun. It's been shown that chemical reactions caused by this high degree of energetic radiation could cause oxygen in the rock to combine with free and available hydrogen to form water, which then immediately goes into the rock in the frozen form. A modest amount of water ice can be formed this way. The other speculation is that the moon got its water in a version of where the Earth got its water, by being carried there mostly in the early days of the solar system by comets and asteroids from further out in the solar system. Some combination of these two mechanisms probably explains where the lunar water comes from. A year or so ago, lunar orbiters viewed an amazing place where if we wanted to set up a lunar colony, we'd have a big head start. It was essentially a vertical lava tube with a translucent dome 100 meters across and a vertical drop of over 100 feet. Plenty of volume to harbor a colony of substantial size, and already protected from the ultraviolet radiation of space by the translucent dome. All we need to do is set up the oxygen plant and the water plant outside, mining the local rock, and that's enough to sustain a colony. Of course, we know a lot more about the moon than any object in the universe because we've been there. You may be aware that in Gallup polls, somewhere between 5 and 10% of the American public believed that we did not go to the moon, that it was a hoax, a government conspiracy if you like. And even for me, who was a young child when I saw that on a grainy black and white television, it seems like a dream. I doubt that Harrison Schmitt, the last man to set foot on the moon, imagined it might be over 50 years before we go back. So was it a dream? No. Orbiters can clearly see evidence of what we left behind on the lunar surface. Tracks from the lunar rovers, the command module debris, the launching pad for the return of the moon astronauts when they came back to the Earth, and even the flags that were planted there. Not only that, the Apollo landers left behind geological testing equipment that has been returning seismic data since the late 1960s. We definitely went to the moon. And how do I view the 5 or 10% of people who think it was a hoax? I don't know. Occasionally I get annoyed by it, and other times I just think, well, if you make a list of the things that are crazy that 5 or 10% of the population believe, it's a list with some pretty interesting and crazy things, so maybe moon hoax just fits in that list. Either way, it means we have a little work to do to convince those last people of what really was one of the most magnificent achievements of the last century. And if you can't make a good argument, sometimes you can get even. Buzz Aldrin, second man to set foot on the moon, has been hounded by a filmmaker who claims that it was all a hoax and is not willing to keep that opinion to himself, but takes it to Aldrin directly, and you can see the result.
You're the one who said you walked on the moon when you didn't. Calling the kettle black, if I ever thought of it. Saying I misrepresented myself.
Away from me.
You're a coward and a liar and a thief.
Our closest twin in the solar system was named after the goddess of love. And when you learn a little bit more about Venus, you have to imagine that whoever named it must have had a sorry history of dating relationships. Venus is an inferno, an exceptionally nasty place, which has suffered a severe form of the greenhouse effect that we think the Earth may be experiencing right now with global warming and climate change. The surface temperature of Venus is 900 degrees Fahrenheit. That's hot enough to melt lead and for paper to spontaneously combust. The pressure is 100 atmospheres, and the atmosphere, while mostly carbon dioxide, also includes substantial trace compounds that are all toxic. Ammonia, sulfuric acid, acetylene. This is an exceptionally nasty place. But if we run climate models backwards in time, it's speculated that Venus may have been habitable and temperate about 3 billion years ago. It took nearly half a dozen failed attempts before any man-made object landed on the surface of Venus. The Venera 7 lander from the Russians from the early to mid-1960s lasted for 20 minutes and transmitted a handful of pictures before its instrumentation melted. We haven't landed anything successfully there since. Venus's thick clouds are opaque to visible light. We can't see the surface, but the Magellan radar imager revealed the entire surface. Artists can imagine Venus, even if we can't see it. This volcanic world with its toxic atmosphere, its crushing pressure, uninhabitable by any imagination. The inner solar system contains small rocky objects like Mercury and the Moon, with no atmosphere, no geological activity, blasted by craters. Venus is the closest twin to the Earth, and it has a thick, toxic atmosphere built up over time and heated by the greenhouse effect. But otherwise, Venus is a twin of the Earth with similar levels of volcanism. Finally, the Moon has proved to be less boring than we thought. Recent space missions have shown that there's sufficient water ice near the surface to support a lunar colony.